CPM. Critical path method is one of the most popular project management techniques or network planning models, along with the program evaluation and review technique we call PERT. In this course, we will focus on CPM. What is the critical path? Critical path is the path where the sum of the activity times is the longest. This is very important definition. So why it is critical? Because all activities on the critical path must be completed in the designated time. Otherwise, the entire project will be delayed. So critical path is the longest path in the network. So what are the implications? First, length of critical path equals the project completion or duration time. So if you identify the length of critical path, you know the project duration time. Second, if there is any delay on the critical path, the project will be delayed. Similarly, if we want to reduce the project duration, you must consider reducing activities on the critical path. So critical path and completion of the project duration is basically very highly correlated. It is possible and it often happens that there are multiple paths of the same length through the network, so we can have multiple critical paths. Now let's consider steps in CPM. Here is the procedure for scheduling a project. In this case, a single time estimate is used because we are assuming that the activity times are known. Consider that you have a group assignment that requires a decision on whether you should invest in a company. So we identify all activities among the project. So here are the 4 activities we identified, and each activity we have the estimated time duration. Selecting a company takes 1 week, all the way to reviewing data and make a decision takes 1 week. Once you determine the activities, you identify how these activities are related with each other. In other words, you are identifying immediate predecessors. If there is no immediate predecessor, that's the first activity to start. Now we draw a network diagram and determine the critical path, which is the longest path in the network. Here, activity A has no immediate predecessor, so first activity to start. And we have activity BC happen after activity A is done, and final activity is D. How many paths in this network diagram? We have ABD and we have ACD. ABD takes 4 weeks and ACD takes 3 weeks. So in order to complete this network, project, we have to complete these activities, but these 2 paths are included in the network, and longest path is the ABD, which is the critical path. That determines the duration of the project. So 4 weeks is the critical path, at the same time project duration. Now we have to schedule the project. So we use the early start, early finish, late start, late finish time. Each early start, finish, late start, late finish, we place in the special place. So step 4, we determine the early start, early finish time using the forward path. Start with early start time and go forward in the network from A to D. So to calculate these numbers, we start from the beginning of the network and walk to the end. That's the we call forward path. Start counting with the current period, designated as period 0, And activity A has an early start of 0 and early finish of 1 because 0 plus 1 is 1. Activity B is early start is 8, early finish time which is 1. Similarly, activity C's early start is 1. And early finish time for B is 3 and early finish time for C is 2. Now we consider activity D. D cannot start until B and C are done. Because B cannot be done until 3, D cannot start until that time. Early start for D is therefore is 3. And early finish is 4. 3 plus 1 is 4. That's the early start and early finish times. You have to remember that whenever there are conflicting numbers or predecessors, then earliest start time for the task, in this case activity D, you have to choose the maximum or largest earliest finish time of all predecessors of that task. So we have a two conflicting number, 3 or 2, then we take the largest number for earliest start time of that task. Okay, now we have to determine late start and late finish times using the backward path. So we can start from the end of the network and walk toward the front. Consider activity D, last activity. The earliest that can be done is at time 4. And we do not want to delay the completion of the project. Right? So late finish time needed to be set to 4. This is the early start finish time. This is the late finish time. We want to set to 4 so that we do not want to delay this project. With the duration of 1, the latest that D can start is 3. Now consider activity C. C must be done by time 3 so that D can start. So C's late finish time is 3. Its latest start time is 2 because 3 minus 1 is 2. Notice the difference between the early and late start and finish time. This is early start, this is late start, this is early finish, this is late finish time. These numbers are different. That means we have a 1 week slack time. So I will explain later. Activity B must be done by 3. So D can start right away. So its late finish time is 3, late start time is 2, is 1. 3 minus 2 is 1. There is no slack because late start and early start is equal to 0. Finally, activity A must be done so that B and C can start. Because B must start earlier than C, and A must be done in time for B to start. The late finish time for A is 1. Finally, the late start time for A is 0. There is no slack in activity A, activity B, and activity D, except C. Notice that if there is the two conflicting numbers, the latest finish time for the task, we can choose the minimum or smallest latest start time for all followers of that task. So we choose 1 instead of 2. Now let's consider why early start and early finish, late start, late finish times. What these are about. To schedule the project, we should know when each activity needs to start and when it needs to finish. The point is that we do not want to delay the project In other words, we want to finish the project on time. So that's why we are scheduling this early start and finish time, late start and finish time. In other words, we want to find out what are the slack or flow time, because slack or flow time is the time between early start and late start time. The difference between late start and early start. And slack is very important because slack is the amount of time that activity can be delayed without affecting the project completion time. And critical path has no slack time. In other words, you have to finish the project on time. You have to finish any activities on the critical path on time because there is no slack. If there is any delay on the critical path, that will affect your project completion time. But slack is no, because slack time is the amount of time the activity can be delayed without affecting project completion time. So late start and late finish time are equal for all activities on the critical path. Let's find the slack in this network diagram. Our critical path is A, B, D because that's the longest path. Now any activity on the critical path, A, B, D, has no slack because late start and late finish, late start, late finish, late start, late finish is 0. 0 minus 0 is 0, 1 minus 1, 3 minus 3. What is the activity with the slack or flow time? Activity C. Why? Because late start minus early start is 1. So 1 week slack on this activity C. So ABD must be done on time in order not to delay the duration of project. But C has 1 week flexibility. You can delay by 1 week without affecting this entire project duration. So why slack or flow time need to be included in the project? Deliberately adding slack time into your project timeline is a smart way to stay on schedule. You can read this article posted in the D2L website that will show you why smart managers, project managers include slack in the project. Project management professionals know that the unexpected is the one thing you can always count on. Therefore, flexibility is the valuable project management tool. Slack time allows a project manager to delay a task when necessary without affecting the rest of the project schedule. In other words, slack time means that holding off on task A will not prevent the on-time launch of task B. Finally, slack time is normal. It's not something special, it's normal. As a project manager, you can identify and minimize it, but you won't likely be able to avoid the slack. These are the 3 important reasons why slack or flow time need to be included in the project. Okay, that's it for the brief overview of critical path method. The next slide, next video lectures, I will explain some of the problems of critical path method.